You're going to start by zeroing it out. We'll FOIL it real quick, or distribute it, I should say, 2r plus 8, right? So r squared minus 2r minus 8 is less than 0.
Percy Dean, Kate Cole, and Kate Panic to the office, please.
Unlike the previous example, the product of whatever this is less than 0. And what kind of numbers are less than 0? Which means the product of this is a negative. Let's factor it real quick and see what that means. R minus 4, r plus 2. Bailey, check me. Good? Okay. That means that this situation's product results in a negative. How can two factors multiplied together give a negative? One's a positive, one's a negative. Solve it like this. Let's make this one positive and this one negative in the left. R minus 4 is greater than 0. R plus 2 is less than 0. Okay, that is one version of the solution. Both of these things must be true, A and D, in order to create a negative product. On the right, we'll make that one negative and the other one positive. R minus 4 is less than 0. R plus 2 is greater than 0. I know you think, wait, that's crazy. You're flipping signs around. What I'm doing is I'm manipulating the equation, the inequality, so that I'm able to come up with numbers that will make this a true statement. And because I know the laws of multiplication, I know that one factor must be positive and one must be negative in order for the circumstances to create a correct result. Solve real quick. R is greater than 0 and R is less than 2. Greater than 0, less than 2. How about 4, Mrs. Myers? 4, greater than 4, less than negative 2. What do you think of that? Doesn't seem like it'll make a lick of sense, does it? What number is greater than 4 and less than negative 2? Nothing. This offers you nothing. No solution to that side of the fence. Nothing. But on this side, R is less than 4 and R is greater than negative 2. What can satisfy that? Everything in between. So this means negative 2. I'm just going to cheat on my graph here. That anything bigger than negative 2 but smaller than 4 should work. This answer created nothing that's usable. You can't even consider this answer because there's no numbers that satisfy this rule. But this is true. This can be a real world situation. Now I want to test something. I always test something that seems to fall within the shaded area, leading to me to believe that it's true. I'm going to test that 0. And I'm going to test that 0 in the original equation. 0 squared is less than, well, 0 is going to be kind of a pain. Yeah, let's do 1. Because it's 0. Let's do 1. 1 squared is less than 2 times 1 plus, oh, I guess it would have worked, 0 plus 4. So 1 is less than 2 times 4, which is 8. Yeah. If I tested the 0, 0 squared is less than 2 times 0 plus 4. 0 squared is less than 8 would have been true as well. Okay? So that's true. If you wanted to test the outside to prove that these outer sides were false, you would find that the outsides are false as well. Now, the testing, like I said, is going to be your saving grace. And when I show you example 3, you're going to see why. Because the way example 3 looks in the textbook, to me, is very, very difficult. So I do not use the way the textbook teaches it. I use the see what might work and test. Okay? Because the way they teach it, it's very difficult. I've never been comfortable with it. So I'm going to show you example 3. Here we go. Example 3 is a cube. Example 3 is y cubed minus 16y is greater than or equal to 0. It's already been zeroed out. I'm going to pull out my y, which gives me y squared minus 16, which is a difference of squares. Okay? y plus 4, y minus 4. Is greater than or equal to 0. Okay, the way I do it is I solve like an equation. Okay, and you can look over the way the book shows you. I hate it. I solve it as if it was an equation. Okay, so y equals 0. Y plus 4 equals 0, which means y is negative 4. This one, here's the second one. The third one, y minus 4 equals 0, so y is a positive 4. Now I solved it like it's an equation, okay? I will graph each point. Here's what I mean by that. And these are greater than or equal to's, so they're solid shades. Okay, you're going to shade them in solid. So negative 4, negative 5, negative 4, 0, 4, 5. You're going to see why I'm putting other points on there. 0 is a solid. Negative 4 is a solid. Positive 4 is a solid. Next, and this is, again, it's a pain, but it's the easiest way to do it. I test here, 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 and here to see what gets shaded. Okay, I know you don't like the idea of doing that, but trust me, it's easier than the method they've got. So we're going to test the negative 5 in the original. So last step, test. Okay, and you could plug it in here if you like, because that's actually pretty easy too. So let's do negative 5 cubed, thank you Bailey, minus 16 times negative 5 is greater than or equal to 0, question mark. So give me the numbers here, because you guys will be quicker than me, and I know we're running short on time. Yeah, negative 5 times. I'm going to run out of time. I shouldn't have even tried. 5 times 5 times 5 is negative 120. Is this true or false? Greater than or equal to 0. No, that's false, isn't it?
Wait, how did you get 80?
That's false. 125 negative, 80 positive, negative, negative. That's going to be false. So this is a no. We're not going to shade here. Negative 1, let's test that, because that one's nice and easy. If I ran out of time, I'll just keep going. Negative 1
No.
cubed. Negative 1 doesn't work?
Chloe and Tara Ewers to the office should be leaving for the day.
Negative 1 cubed minus 6